Okay, let's get started. I'd like to welcome everybody to today's community call, our first one of Phenotype April. This is going to be a live demo, live build of cohorts. Gowtham is here. I know we want to try to make this interactive if possible, so I'm going to kind of move through the updates fairly quickly, maximize the time. Certainly, though, if anybody has anything they want to share, please just unmute, stop me, and please do share. Uh, this is going to be Phenotype April month, so next week we will have the Keeper evaluation session. Patrick Ryan will lead that. Following week will be the Europe Symposium, so we'll take off for the community call. We'll have a final evaluation and learnings at the end of the month, and then May 5th, any kind of wrap up we need, plus a review of the Europe Symposium. So that's what we have coming up over the next few weeks. Please do remember about the April 21st no meeting. All right, three publications I'd like to highlight. First one, 17 co-authors in Medicina, a multi-center propensity score matched cohort study of preoperative antiplatelet therapy and postoperative outcomes in elderly surgical patients. 6 co-authors in the Journal of Clinical Medicine, Temporal Trends and Clinical Implications of Cardiac Troponin Testing in Emergency Departments, a multi-center retrospective study. And finally, 26 co-authors in the European Journal of Epidemiology, Cohort Characteristics in our package for popular characterization in observational studies using the OMOP Common Data Model. Quick look, does anybody from any of these studies want to share anything about any before I move forward? Okay, please do check them out on the community calls page later today. Busy week for work groups, starting really tomorrow and Thursday. 10 work group meetings over those days, but 16 overall before our next community call. Any of our work group leads or any members of the work groups want to share what's on the agenda this week, or just anything that they want the community to know about with what's going on in their work groups? All right, a reminder, a number of our OKRs have been updated on the work groups page. So to learn about what's going on in the work group, maybe where you can fit in, what you might want to join, please do check those pages out. I know this was mentioned last week, but want to make sure we really highlight the fact that registration and call for participation is now open for the Global Symposium. It's going to be October 20th to the 22nd at the Hyatt Regency in New Brunswick, New Jersey. The event page is up online on odyssey.org, so all the information you need is right there. Please do check it out. The information is also in our April newsletter, which went out last week. The latest newsletter includes, besides details on the Global Symposium, an update from the vocabulary refresh, the My Journey video this month. It's a profile of Evan Minty. Our collaborator spotlight focuses on Inez Renicky, community updates, publications, and presentations from March, and plenty more. Please do check it out. If you didn't get it in your email, you can find it on the Global Symposium. The drop down under newsletters has both the April newsletter link and a link to subscribe. We send these out at the beginning of each month, so please do check them out. I'm going to run through the big events that are coming up over the next few months. We've really talked about all of them. Again, please do stop me if you want to share anything. The Europe Symposium is now a couple weeks away, April 18th to the 20th. Workshops and tutorials, 18th and 19th. Main conference on the 20th. It has been sold out, so registration is closed, but certainly everything you want to know about it is here. There will be a teaser for the events at our Europe community call, which is Thursday morning. So if you want to learn more, please check that call out. Our maternal fellowship is open. We've talked about this a couple times. Key here is application deadline is May 15th. So the link, all the information is on our community calls page. Our OMOP school in Stockholm, Sweden is May 26th to the 28th. The first Latin America Symposium is July 30th to 31st. The DBMI Odyssey Summer School is June 22nd to 26th. Again, all of the links, more information, details, registration, everything you need is on our community calls page. The UK symposium is going to be September 18th, a training day on the 17th. Registration will open later this month, April 20th, and the abstract submission period is open. That'll close on May 1st. The OHDSI Social Showcase continues to highlight the research from last year's Global Symposium. Please make sure you're following us on LinkedIn, Twitter, X, Instagram, and Blue Sky to learn about the research that was presented and hopefully share with your respective networks. I know I went fast there. We'll certainly talk more about each of these events as we go. But anything else that anyone wants to share? Otherwise, I really want to maximize the time for Gowtham. So without seeing any hands, without further ado, I will turn it over now to Gowtham to lead our session today. Gowtham, go ahead.
Great. Thank you, Craig. Can you hear me?
I can.
Excellent. Okay. So I'm going to try to share my screen here. And I'm moving it aside so you can see it.
Yes, I can see it.
Excellent. Okay. Good morning, everybody, and very excited to start Phenotype February in April, or April as we made it up. This is week 1 of Phenotype, and we are doing phenotype development. So my name is Gowtham Rao. I'm a CEO and founder of a new company called coreason.ai, and I've been a long-standing OHDSI collaborator. And the way I was thinking about today's discussion is how to get a black box to reliably and reproducibly build phenotype algorithms, and to do it better than humans. Wouldn't that be cool? So can we get there? So this whole month, we're going to be talking about this black box. And Patrick introduced the idea of a black box last week. And the idea here is, given a clinical intent, can a system, maybe if it's running a large language model, predict tokens with such reliability, such reproducibility, that it can build core definitions better than humans? So this is a slide that we have seen several times. We have been trying to build an open science system, a system that is able to build and establish trust in the evidence that we generate from real world data. And we have envisioned this as a series of waterfalls that in each step, a decision is made by the system whether to move forward, to go or to no go. And we've achieved good progress in this, especially in the analysis reliability specification or analysis reliability evaluation, that is study diagnostics, where we have pass or fail. We have some for data quality, but we absolutely do not have anything for phenotype development evaluation. And this is our biggest need, it's right in the middle, and we do not have any go, no-go decisions for phenotype development and evaluation. So maybe a system can do it. So this week, we're going to talk about phenotype developments, where I'm going to talk about building cohorts, but thinking from that systems perspective. Next week, Patrick and Martijn are going to talk about phenotype evaluation using a new tool called Keeper. Keeper's been around, but has been significantly upgraded by Martijn, and he's going to show it. And in that interactive session, we'll learn about why certain cohort definitions have certain types of measurement errors and what we can do to improve on them. Week number 3 is a break. That's because there is the European Symposium, but that doesn't mean we are not available. If you want to build cohort definitions, this is the time for us to all work together and to build more. And I have a lofty goal for this month. We have one clinical idea, and I want to build more than 100 community submitted cohort definitions for just acute myocardial infarction. So this is the time that we can work together on that. And then on week number 4, we'll run them all through this evaluation pipeline, this black box, this system, and see what the performance characteristics is of all these cohort definitions. So Azza Shaibi and I lead the OHDSI Phenotype Development Evaluation Work Group. We meet once a month in the last last Thursday of the month. And this is our OKRs. And this year, we want to advance the science of AI-assisted systematic phenotyping. And this is an this is an objective that we share with the AI work group that is led by Marta and Shumi. And the first key result is to conduct Phenotype February. But here we want to benchmark a new workflow, an improved workflow that is AI assisted. And we want to check how that works. And we are doing that as part of Phenotype February, Phenotype April. So this is not the first year that we as a community have been doing Phenotype February. We've done this for several years. This is the 5th iteration of Phenotype February. And all the things that we have done is in the open. That is, it's on the forums, it's on GitHub, we have YouTube videos of it. That means a system, an AI system, can learn from it. So I asked a large language model to explain what it knows about Phenotype February, and it gave me this nice visual. And I think it's doing a good job. It's not precise, but it's directionally good. It is a community-driven effort. We are pursuing a scientific challenge. It is a scientific exercise that we bring together epidemiologists, clinical experts, data scientists, and now we're going to bring AI developers to the picture. And more importantly, we are very transparent on what we do. We are very rigorous. And we usually take a few clinical ideas. In the first Phenotype February, we took 28 clinical ideas and we did one every day. That was very heavy. But this time, we're just doing one, acute myocardial infarction. The entire month is about acute myocardial infarction. And we're going to do it live. We're going to do it collaboratively. We're going to do it openly debating and talking about different ideas. And we're going to test new tools. And I like that this visual has already captured our workflow and has described the Keeper system. Now, Keeper is a novel idea which we will see next week, which if we can describe it as like an AI clinician. It evaluates if a person who's in a cohort truly has the disease from a biological perspective, from a clinical intent perspective. And that's interesting to me. And then then it also, this diagram, try to capture what I think is the early signs of how a system could do phenotype development. If you think about how we as humans develop core definitions, we think about understand the clinical idea, and then we pick codes. And this picking codes is truly a very creative process. Why do we pick one code over the other? Nobody really knows, but we do. We make choices because, in my opinion, that is a better code versus the other. Or maybe there is an empirical way to assess it. But can a probabilistic model pretend to be that creative and also propose ideas? So maybe it can propose. And if it can propose, maybe another model can verify it by generating SQL code and running it on a database and getting some numbers back. And so it can be deterministic. So the deterministic LLM could tell us if it actually increases or decreases a certain measurement error, while the proposer can come up with various creative definitions like a human does. So we have a proposer validator framework that is possible these days with AI. So not many of us are familiar with the terminologies that we use, so I'm going to introduce some of the terminologies very quickly. We have an idea of a phenotype. The phenotype has an official definition that was introduced by George Ripschak and others in 2018, but colloquially, we describe this as a label that is used to describe a clinical idea, that one clinician, if it describes to another clinician, can understand it. But then how do they describe it? We use the term case definition to describe the individual level criteria that clinicians use to classify a person as a case. And this includes their observations, their measurements, or any lab results. While a clinical description, on the other hand, is like a paragraph in a textbook. It's a group level information about what the gender distribution or the comorbidities and the treatment patterns for this population or this cohort of people. That's a clinical description. And we take these as inputs and we go through the phenotyping process. And the first step is to systematically build and model that target clinical idea in a tool like Atlas or Paper. So we allow people to enter based on some code, and then we apply several temporal rules. And we finally run it on one or more data sources. When this algorithm is run on one or more data sources, we get a cohort. And Patrick talked about the cohort in the last session. In OHDSI, a cohort is a special meaning in terms of an actual physical table. And this cohort has measurement characteristics. Measurement, you can talk about operating characteristics in terms of sensitivity, specificity, positive predictive value for the clinical idea. And we can assess it with some tools. So this was a slide from Patrick last time. He said the current phenotype development is very subjective. It's also labor intensive. It's a lot of work. One cohort sometimes may take several hours to build. But maybe we can use a black box that, if you give it an intent, some description of a clinical idea, it processes it through some methodology, maybe magic, and produces an output, right? A cohort definition. Now, if you told me that this is possible 3 years ago, I would have said no, absolutely not. But last year at the OHDSI Global Symposium, we actually had some scientific proof. We did a control experiment, a randomized experiment. We had one arm where the best of humans in the OHDSI community worked together, almost like an ensemble of people building concept sets. And then we had the intervention arm. We had 4 AI groups, and each LLM-based process was building concept sets, and we found that it was actually not inferior to the humans. And that was one of the first scientific evidence, probably, to show that building codeless with an LLM is possible, and it does a good job. So we know that we can build concept sets inside the black box. So if you think about building code definitions using a tool called Atlas, we have an initial entry event criteria, we have inclusion criteria, and we have exit criteria. And the blocks inside that are concept sets. And we know that the large language model can build concept sets. And that's been proven in the last symposium. But now, can it build cohort definitions? So Patrick presented a workflow of a black box. Now, I don't believe in black box. I think we can make the black box more transparent. If a large language model wants to predict tokens, maybe we can constrain it in a certain way that it becomes almost deterministic. If we can force a predictive system, probabilistic system, to work in with very strict guardrails, it can approach a deterministic behavior. And that's a neuro-symbolic framework where you can have a proposer and a verifier at the same time. So in this case, given a clinical idea on the left-hand side, a high-level clinical definition, a deterministic system could go through a workflow and build core definitions. And we know this workflow because we have built this workflow over this last many years. And this is the same workflow that we as humans use. We think about our entry event criteria, and the entry event criteria is where we maximize the sensitivity. And then at the inclusion rules, we maximize the specificity. And this is an optimization function that a deterministic system could do. Now, here's the visual where we talk about this entry event criteria. Step 1, we capture persons in the database who may have the phenotype. Now, we want people with acute myocardial infarction. So we look for everybody who may have the phenotype because they have an ICD diagnosis code or a lab result such as elevated troponin levels, or maybe they had a cardiac procedure that suggests that they have myocardial infarction. In the second step, we then restrict persons who likely do not have acute myocardial infarction. Maybe they have some other reason. Maybe it was a rule-out diagnosis. Maybe they had myocardial injury only, but they did not have myocardial infarction. So we use things like corroborating evidence, like we need to have a second code or an ECG or an angiogram, or maybe chest pain. We require them to have certain settings like inpatient or emergency department. Finally, we have the third step, which is to make sure that the date misclassification error is not present, because a patient may have a biological start date, which may be different from their coded date. And that could cause errors when we do time to event analysis. And so we need precision in those dates. So this is the process that we follow. And can we train a large language model to follow this exact process? Can that black box follow this process and be transparent in its workflow? So that's what we're going to talk about. So when I show you the Atlas demo, I would like you to think from a systems perspective, like how would a system build that framework? Now, there are 6 dimensions that was proposed in the last call by Patrick. If you're thinking about acute myocardial infarction, you can think about identifying patients based on the dimension of diagnosis, because a physician who's evaluated a patient may have made a diagnosis, a code for that patient, or based on symptoms. So there might be codes or observations of symptoms. There might be diagnostic procedures. There could be therapeutic interventions. There could be the complications like ventricular aneurysm because of acute myocardial infarction. Or there could be alternate diagnosis that may make the presence of acute myocardial infarction less likely. So I want you to think about these 6 elements as we build core definitions in Atlas. Now, this is acute myocardial infarction, the definitions of acute myocardial infarction. When I did my medical school, acute myocardial infarction was a syndrome. There was no definitions for it. It was very subjective. Then when I started doing my internal medicine residency training in Kansas City, there was this new thing called cardiac troponins. That was the second universal definition. Then came the universal definition of number 3, where there was high sensitivity cardiac troponins. Now we are in the 4th version, where there is this difference between, wait a minute, myocardial injury is not the same as myocardial infarction, because you could have myocardial injury with elevated troponin levels, but just because you have troponin levels does not mean you have myocardial infarction, because you did not have ischemia. You need to have ischemic injury. So the combination of these 2 is what is called as myocardial infarction. And the 5th version that is coming in 2026 is even more complicated with trajectories and age, gender specific strata. Now, we as humans, when we model these in a system like Atlas, we can do some of these, but this becomes really complicated. But maybe the black box can model and understand this as the input, and it can model it in much more finer details. So we are going to try to model the 4th universal definition. It requires 2 things. One is the markers of myocardial injury, which is the troponin level to be elevated. And then the second is a symptom or a sign or a test suggestive of ischemia. So they need to have injury, as in myocardial troponins, and ischemia, as in the symptom, the sign, or an intervention. So I'll now go into Atlas. Now this is a discussion. Please stop me at any time. I would like to hear questions and make it more interactive. So I'm going to pull up Atlas now, and let's see. So I have an instance of Atlas where I have, it's pretty much empty here. As you can see, there are 4 sections in an Atlas user interface. One is called as a cohort entry event, and then you have inclusion criteria, a cohort exit, and a cohort error. When we are building cohort definitions, to maximize sensitivity, we want to add as many things as possible to the cohort entry event. What cohort entry event does is writes a query into the database and pulls persons and dates that matches the entry event. Next, we have the inclusion criteria. In the inclusion criteria, if you put trues in the inclusion criteria, it checks if the person and the time combination continues to satisfy the rule in the inclusion criteria. So if it doesn't satisfy, it removes that person and date combination. So we're going to focus on these 2 ideas, the entry event idea and the inclusion criteria. Now, when I talk to you about the myocardial infarction, one of the ways that a person could be documented to have myocardial infarction in the database was because a clinician, a treating physician, assessed the patient. They looked at their elevated troponins. They looked at and understood that the patient is suffering from ischemia because they may be complaining of chest pain, or they may be having wall motion abnormalities that is new, or EKG changes. And because of those, they have made a diagnosis of myocardial infarction. Now, that is one of the first dimensions of the 6 dimensions that we talked about. A dimension of diagnosis. A competent clinician who's a treating physician has made the diagnosis. So if a patient satisfies the diagnosis, they should probably be in a cohort definition. So how do we build that? So if I go to the cohort entry event and I select condition occurrence, we go to the condition domain. And now remember, we have already solved how large language models and AI system can build concept sets. So voila, the whole concept set list has already been built out because that was populated in the system by the large language models. In fact, I asked it to build concept sets based on the 6 dimensions. The dimensions are numbered here as 01 is diagnosis, 02 is complications, 03 is diagnostic procedures or DP, 04 is therapeutic interventions, 05 is symptoms, and 06 is alternate diagnosis or differential diagnosis. So we're going to use combinations of these to build the cohort definitions, but we're thinking from a systems perspective. The system now has these concept sets. These concept sets fit into these 6 dimensions, and it is trying to first maximize the sensitivity. So it starts with the diagnosis dimension, and we go to the condition, and I'm going to pull up the diagnosis dimension. Now, what we have learned from observational research is that if we want to have a reliable baseline characteristics, we want to make sure that the patient has been present in the database for at least some number of time. And usually we have taken a rule that the 365 days is good. So we usually do 365 days of prior observation time. This allows us to reduce the probability that this patient was just newly transferred into a new health system or a new health insurance plan, thereby we do not have any history about them. So by putting 365 days of continuous prior observation time, we ensure that we have history on them. So I'm going to pull condition occurrence, diagnosis, 365 days, and the default selection is earliest event. I'm going to just make it simple. Myocardial infarction could occur more than once, but I'm going to say it's the first diagnosis of this patient. Now, this by itself is the legitimate, valid cohort definition. And I can save this, and I can run it on one or more data sources, and I will get a cohort. And this completes the first cohort definition by a simple dimension of diagnosis. But the system has access to the recommended codes. this recommended code was part of a community-wide effort, which was initially called Phoebe, and then is now the recommender system led by Anna Ostropoulos. In this recommender system, based on the correlation of other codes, it recommends other codes that we could use to increase our sensitivity of this cohort definition. And when I looked at it, I found several codes that seems to be related to myocardial infarction. Example, cardiac rupture due to and following acute myocardial infarction. Doesn't tell me if it happened on the day of acute myocardial infarction. It doesn't tell me if it happened 1 week after, but it seems to be strongly related to acute myocardial infarction and seems to be a complication of acute myocardial infarction. So the system has built this for me. It has collected all the complications of acute myocardial infarction and put that into a concept set repository. So into concept set expression. So I have a concept set expression that has all the complications of acute myocardial infarction. Now, how would I use this as an entry event criteria? Because if these are people who truly have acute myocardial infarction, then I want them in. I want to increase my sensitivity. So I'll add another rule. And again, I will do complications and I will do the first diagnosis. So now I have a new cohort definition. This cohort definition has two entry event criteria. One is the dimension of diagnosis. The second is the dimension of complications. In both cases, it will result to one occurrence per person in the cohort table. And because this has more codes than just the diagnosis, it is likely to be more sensitive. Now, I do not know about the specificity, but I'm guessing that the sensitivity has gone up. Now, because I'm creative and like any clinician, I'm going to say, wait a minute, I don't think that that code of acute myocardial infarction seen in outpatient setting is a real myocardial infarction. It must be a follow-up care. I need this to be an inpatient setting. Okay, so we can put that as a rule and see what happens. And we'll put that as a rule and we'll say, here as an inpatient visit, now I'm going to put the visit occurrence and I'm going to say inpatient. I'm going to say emergency room or inpatient. And then I'm going to say it should start all days before or 0 days before, and should end all 0 days after and all days after. And there's a logic behind it, and I can explain it to you in the phenotype development work group. But essentially, the diagnosis of acute myocardial infarction should overlap with an inpatient or emergency room visit, because the inpatient or emergency room visit is a span of days. And if any day during that time, if you have acute myocardial infarction, then you are likely eligible. So what I just did was I added an inclusion criteria, and this inclusion criteria removes patients who do not satisfy this inpatient visit. It removes the combination of person ID and date ID where it's not inside an inpatient or emergency room visit span. So if the outpatient visit only acute myocardial infarction is a sign of specificity errors, then we have now improved our specificity without compromising sensitivity. So we now have our third cohort definition. But some may say, wait a minute, I don't even believe that. I want a primary diagnosis. Okay, let's do a primary diagnosis. But remember, I'm just proposing here. I'm a proposer. I'm proposing different types of ideas. I don't know if it's right or wrong. I'm just proposing. And large language model, a system, can also propose, because at the end of the day, it is a creative being. It's probabilistic. It has learned from all our creativity and is behaving just like us. So it can say, oh, I want first position, I want primary criteria and so on. Nothing wrong with it. Again, a valid cohort definition. So now we have our fourth cohort definition that's also valid. It also represents acute myocardial infarction. It has the diagnosis code and complications. It has an inpatient visit and its primary diagnosis. But maybe you don't want primary diagnosis, you want 2 codes. That's fine. So you can change that. You can have condition occurrence. You can go back to your diagnosis and you can say, oh, I want standard concept, but I want 2 of them. And I need it to be within, say, I don't know, 7 days of each other. So I want 2 codes within 7 days of each other. And there you go. Another valid code definition. Each of these, we can keep on going like this with many and many and many code definition, and a proposer system can keep on proposing ideas just like a human can. And the more, the better, because as long as we can evaluate them, we can pick the ones that have the best sensitivity and the best positive predictive value. In fact, we can keep going, and here is another complex code definition that I'm going to show you. This complex code definition involves patients who meet the fourth criteria, but may or may not have a diagnosis. Maybe there are patients who have increasing cardiac troponin levels. They have reported symptoms of ischemia or have EKG changes, but for whatever reason, they do not have a diagnosis code. And they are present in the database. They actually biologically have acute myocardial infarction. And if we don't capture them in our core definition, we will have sensitivity errors. So how do we represent them? So that's with the other new dimensions. So we can add new dimensions of diagnostic procedures. So here we have the diagnostic procedure of cardiac troponins, a measurement of cardiac troponins with 1 day before to 1 day after an emergency room or inpatient visit. Or they can have symptoms and an EKG. Or they could have cardiac wall motion abnormalities. Or they could be tested for myocardial perfusion through a scan. Maybe they went for a coronary angiogram, and they may have have a stent put in. Maybe they got a thrombolytic therapy. All of these are different rules that you can propose. The system can propose. Humans can propose. And each of this is a creative proposal that leads to a valid cohort definition. Now, if I take this cohort definition and I combine with that cohort definition, I probably will get a more sensitive cohort definition, because here it's coming only by diagnosis dimension, diagnosis and complication. Here it's coming from diagnostic procedures, therapeutic interventions, symptoms, the other dimensions. So if I combine them, I will get my more sensitive cohort definition. And in this one, I have the diagnosis, the complication, or the various combinations of myocardial injury as represented by troponins, and myocardial ischemia as represented by symptoms, so EKG changes, cardiac wall motion abnormalities, coronary angiogram, or thrombolytic therapy, all markers that some infarction has happened. But I'm not satisfied here. I may have some false positives here. Maybe the patients had an alternate diagnosis. Maybe they had a diagnosis that was myocarditis, and they initially were diagnosed with acute myocardial infarction. So I may propose that any patient who's had a diagnosis of myocarditis at the same time as acute myocardial infarction does not have acute myocardial infarction. That's my creative proposal. I could do that. So if I do that, then I want to take them out. So I'm going to add rules. I can add rules as many rules as I want. I could add more rules to say, I want to remove people exactly 0 or who have some other cardiac diseases at the same time, like myocarditis or pericarditis or pulmonary embolism or dissection of the artery, or maybe cardiac tamponade. You may debate it and you may say, no, that's not correct, or somebody may agree with me. But that's all proposals, and that's all part of the creative thinking that we as humans can do, and so can an AI, large language model. So we can add more rules. Why stop at just cardiac? We can talk about chest wall injuries. Maybe they had a rib fracture. We can think about lung diseases, maybe pneumonia, maybe pneumothorax.
Gowtham, we have a couple. Gowtham, I'm just going to stop you.
Oh,
Aza raised her hand, and there's a couple of questions in the chat. So let me
that's great. I'm sorry.
stop.
Thank you.
Yeah, I actually want to say, I was going to say exactly that. I was just waiting for Gautam to finish that last inclusion criteria. Maybe Gautam, you can open it for a discussion. There are multiple questions on the chat, and I know you can't see it.
That's exciting. So, absolutely. So this is my last slide, but basically the point being, you can now go with the proposal and build on multiple core definitions. And finally, I'm going to show you my last slide, which is here. So this is just talking about all different reasons for false positives and false negatives, and I can go to it. But I showed you 9 core definitions. I gave this to Martin just about an hour ago, and he ran it through his new system, and it's telling you the sensitivity and the positive predictive value on one data source. And as you can see, each of those core definitions had slightly different length of the blue line, which is sensitivity, and the length of the red line, which is the positive predictive value. And you can see there that the positive predictive value kind of went up, and that's with the addition of the inclusion rules, and the sensitivity went down as the positive predictive value went up. And we'll talk more about the trade-off and the reasons for those trade-offs in the next Phenotype February call. So I'm going to stop here.
Yeah, so we have many questions about the atlas and the definitions you built. So I know you got to, maybe you can't see the chat. Maybe we start, let's see. Yeah, if anybody wants to raise their hand, while I'm gonna try to read some of the questions, but if somebody put a question in the chat and are comfortable just asking it out loud, it's the time for our discussion. We have 15 minutes. Okay, Gautam, so we have a question. Okay, maybe we'll start with Christina, who is it? I can't see the name. Kristika, yeah, and I will go next.
Can you hear me okay?
Ahead.
Yeah, thank you. Great presentation. My question is, will this AI assistant that suggests concept sets, can it be integrated into Atlas?
So let's break down that loaded question. Can be technologically, absolutely yes. Will be, that's a community conversation. The community has not made a decision on it. I do not know. We have to call the OHDSI Atlas working group if they want to do it. But I know there are people in the community who have done it, and we would love to know from their experience about the feasibility of implementing such a tool. I think if your follow-up question is, can we do it from a core definition perspective? I think that's also something that we need to experiment and see. I mean, if this is a scientifically valid process, I do not see why we as a community should not support it.
Thank you.
And maybe Gautam, to add, there are multiple people across the community that are working for solutions related to that. So it's not like 1 or 2. I know there's multiple. When we did the challenge in the symposium last year, we had already in the committee 4 people working on that problem. And even if it's not in Atlas, it's an open source community. A lot of these people put their code in the public, so you can run it, including the people who participated in Minds Against Machine. And currently in Atlas, you have a recommender system called Phoebe. It's not an AI, but it is quite as good if you can look at it. And that's a recommended tab in Atlas. I don't see other hand, but I have a question from Valentina. She's asking, but are there not normative definitions of epidemiological case potentially slightly different between different countries? I guess that's an issue that we encountered as a global community. For example, maybe in Brazil, South Africa, there was a case where Gowtham, the definition, and maybe Valentina refers to the clinical definition of MI may be different across different countries. I don't know, Valentina, if you want to add some context, or was that your intent about the clinical definition?
Yeah. I got some answers on the chat, but thank you for raising it. It's just, and also I apologize for being a very basic question. It's just I have shied away from phenotyping since I've been in the OHDSI because of the data, the nature of the data we work with. That doesn't really, it's like, it's registry based, so it doesn't really give much space for, you know. But so when we did a study with South Africa, we, you know, it was about syphilis and TB, and they were working with EHR, so they had to do the whole phenotyping, you know, extracting from the data sets. We had registry information, but our registry information defined syphilis and TB in one way, and their national guidelines defined syphilis and TB slightly, it was ever slightly different ways, but we understood that that was research limitation because we were not defining, even because the treatment is not, you know, the mandated treatment, normatively mandated treatment for these two diseases is not the same, blah, blah, blah. So I was wondering, for example, in the US, do you not have like nationwide normative definition of certain, I don't know, maybe diseases of specific interest or cases? I don't know. Oh, and I wonder if that factors in at all when you're phenotyping.
So from a clinical perspective, there are professional organizations like the American College of Cardiology that provides guidelines for their members and for the general clinical community on how to diagnose and manage certain diseases. In this case, acute myocardial infarction. So they are trying to build the fifth criteria, unified universal criteria for acute myocardial infarction. The American College of Cardiology, I think, works very closely with the other professional organizations across the Europe, such as the European Society of Cardiology, and they provide a more universal definitions. If another geography has its own definition, either because of the reasons that is unique to the local population or for other reasons, from a real world data analysis perspective, their definition just becomes the intent. What intent, what clinical idea are they trying to model? And as long as you can give that intent, we either as a traditional process using the heuristic that I talked about, or through this new black box system, AI system, we can do our best effort to model it. And when we model it using cohort definition, one or more cohort definitions, we get the cohort and we see if those patients have that clinical idea, that intent. If they do, then that's a true positive. If they don't, it's a false positive. And that's your indication of measurement errors. And if the measurement errors is beyond a certain threshold, then you say, stop. I'm not going to use this cohort definitions. I cannot do this study because I have so much errors that it'll just give me bad results and uninterpretable results. So the general framework is still the same, whether you have different, even though there might be differences in the definition of acute myocardial infarction by geographies. We just want to make sure that we do not have measurement errors when we model it.
Gowtham, another question, maybe you explain for everybody who are not fully familiar with Atlas, how Atlas deal with the entry criteria when you put multiple entry criteria. Is it or and how does it deal with the inclusion criteria when you put multiple inclusion criteria?
Yeah, absolutely. So I'll go back to showing the screen here. So if you notice here, and I love Atlas user interface because it is so well documented. And you can look at this question mark here and you can get a pop-up which also tells you a little bit more about what that section does. But here in the cohort entry event, I have many boxes, and I can move these boxes just to show you what those boxes are. But I have 3 boxes here. And these 3 boxes, if if events having any, so that's an or. If you have any one of these, you're in. Now, that's different from the inclusion rule because they build on top of each other. And the inclusion rule, you have to satisfy all of them to be left in the cohort table. So you can have to satisfy any to enter, but you have to satisfy all to stay.
Yeah, perfect. Then we have another very loaded question, which is going to have multiple answers. But we have a question of, you talked about concept sets and being produced by an AI or selected by a human. But the question is, could you please explain how AI can assist in developing concept set definitions?
Yeah. So a concept set at the end of the day is a concept set in OHDSI, in Atlas, is an expression that when run on OMAP vocabulary table resolves in a list of concept IDs. So it's an expression, it's a formula that resolves into a list of concept IDs. Now, each of these concept IDs has a concept name that semantically means something. It could be a SNOMED code that says acute myocardial infarction. And if you ask a human being, does acute myocardial infarctions, the word acute myocardial infarction, semantically mean acute myocardial infarction, they will say yes. But if you say, does the word congestive heart failure semantically mean acute myocardial infarction, they're going to say no. Well, that semantic meaning, that interpretation is something that the large language models are trained on. And so you can go and give it each code at a time and say, given this clinical idea, does this phrase or series of words mean that idea? And so you can do code selection using a large language model in that way.
Yeah, and as I said before, there are multiple approaches that people are working in with using AI to select codes, whether or select concepts. That was the coverage of the Minds Meet Machine last year. But what we have observed across just looking at the literature, what we have recently, so that OMAP vocabulary is on itself is an ontology system. It has some knowledge in it, and using that on top of AI is probably our best performance. So learning from how concepts are related to each other through the structure of the ontology, and on top adding semantics and interpretation from a language model would probably assist in that concept set selection problem. Oh, we have a hand. Daniel?
Yes. First of all, great presentation, Gowtham. I'm really looking forward to the remaining work for the rest of the month. I just wanted to do a quick plug for a colleague down in Australia, the OMAP-graph framework, and it's currently open, and you can take a look at OMAP-graph, and she's doing exactly what Asa just recommended. So Georgie has made that public, so it's really a really cool tool to take a look at, and we're trying to implement that here at Emory as well. But just a quick plug for a really cool tool.
Oh, see, this is it. This is what Phenotype February is all about. It's about the community openly talking about ideas and collaborating. That's excellent. I will look it up.
And maybe, Gowtham, we can add on the forum post an invitation for people who are willing to share their approaches or codes or packages related to concept selection. Since I know from this call there's a lot of interest in that. People can share it and we can have a forum post about it. I know my colleagues in J&J have worked on Phenolopy, which is also like a very nice workflow, which uses the same idea. And then we have, maybe the same, the topic we always, as a global network, we have different data available across the system. And there are the US things related to US data sources. There are things related to EHRs, which might not be the same as claims. So Gowtham, from a phenotyping perspective, could you address the issue of how we're working on standardized or try to harmonize our phenotypes, given that we have different data sources with different underlying populations, but also coming from different systems and healthcare?
Yeah. So this touches on a controversy and where people have taken sides. But what do we do when there is a data source that only has structured diagnosis codes and procedure codes, and there's another data source that only has lab results and type notes? If you build a code definition that's built on structured codes like SNOMED or CPT codes and so on, it will get 0 hits in your other data source that only has lab results and notes and so on. And on the other side, if you build a definition that is custom for an electronic health record system, you will not get any records in the structured claim system. We have found creative ways to solve this. One of the creative ways is what I just showed you. You can have a diagnosis of myocardial infarction as one entry event criteria. You can have a combination of myocardial injury and signs of ischemia as the second entry criteria, and they can be part of the same cohort definition. So in that particular cohort definition, it will run fine on an electronic health record-based system, where it will have good performance characteristics because it has the lab results and the signs of ischemia. But it will also work fine in the claim system because it has the diagnosis code. So we have done this. It's more complex, it's more difficult, but it is possible.
Yeah, and another idea that we have learned from really across the years with Phenotype February, working across different data sources, and even Asya can maybe talk more about that in the oncology domain. But the idea of a phenotype performance is a characteristics of a phenotype on a given data source. So I don't think we should think of a phenotype performance as there's one definition and it's going to perform similarly across different data sources. The performance of self of a phenotype definition is a function of a definition in a given data source. And that's the beauty of having a network, that we have the chance to be able to look at those measurements error across different sources of data and understand which definition worked best for which data, and also understand which definition can generalize across data sources, which can be a situation where we need that for a network study and so forth. I don't know if others have from the experience to add to this. I know Daniel, you have.
Well, a question to what you just indicated, I think that it is an extremely powerful thing for our community, and the function of PPV being associated with a specific data source is an important one. And I'm wondering if there is currently any repository where there is the reporting of PPV for a specific phenotype at a bunch of different sites. I'm wondering if there's an accumulation anywhere going on right now.
Yeah, it's called the OHDSI Phenotype Library. At least when it was originally designed, it was supposed to capture all those things. And unfortunately, it was a lot of work, and it's as a community project, it's a little bit slow. But hopefully, we'll restart it, and we can have everybody in the community contributing the measurement information in their data source. Okay, Craig, we're on time.
Craig, back to you.
Yeah, I didn't want to interrupt your Q&A, but I want to thank Gowtham for leading this session, and it's great to have the back and forth at the end. So we do want to try to have that happen as often as possible, moving forward in these conversations. So again, thank you, Gowtham, for this session. The video and the slides will be posted on the community calls page later today. We'll keep Phenotype April going next week with a session that'll be led by Patrick Ryan. Thank you, everybody, for joining today. Have a great day. Have a great week. We will see you next week. Bye, everyone.
Oh, bye.
Bye.
Thanks, guys.